Interface segregation. So we are talking about we are summarizing solid design principles. So after Liskov substitution, we have interface segregation, and interface segregation comes into picture when we have a class. So I have a class. Class is used by another class. So there is a kind of a client component and there is a service component. Client component depends upon service component. Okay, so it is a implement. It is a kind of a tight coupling. Means whatever the implementation we have in the in the service class, the uh, the client component depends upon the service component through the kind of implementation code. So that is the concept. So what is the problem that we see that we go for interface segregation? So that is what we want to see. Now suppose there is a printer. So there is a printer. I think this is a famous example. So there is a printer. Uh, there is a there is a client component. There is a service component called printer. So client component depends upon service component in the sense that client component calls service components methods. So printer is a class that is instantiated and it is used by the client component. Now client component uh, fires printout and printer prints the data. But now suppose that printer supports faxing also. So whatever printout is fired, those are being faxed also, and stapling is also new thing that is available here. Now inside the printer class, it does printing, it does faxing, it does stapling, all three. Now all three code, okay, they can see each other. So the methods of printing, method of faxing, and method of stapling, all three group of methods, they are exposed to each other and they are intermixed. The code for the printing, faxing, and then stapling, they are completely intermixed. If that is the scenario, then see the problem. Now there is a client component, there is a service component. Service component is a printer class. Client component depends upon the service component. Depends upon means it uses the service of the service component. Service component earlier has only printing, now it has a stapling and faxing also. If that is the scenario, then stapling and faxing and printing code are intermixed the way it evolved, and they are calling each other here and there. So the printer code is completely mixed. If there is change at one place, then all two other places need to be changed. So for minor change in faxing also, printing and stapling code they also comes into effect. So it takes lot of time at the printer class to modify one thing. Second thing is the client component and service component. Client component is directly using the printer class object, and it is also messed up with the stapling and printing and faxing code, all three. Suppose that the client code cannot be written with the specialization. Client code is only one. Okay, so client code receives the printer class object, and then it writes its own algorithm based upon the printer class object's methods. So that is the scenario. Now it uses methods like faxing, but tomorrow, so faxing I can think as communication. So printing, communication, and binding. So there are three departments. Now against the binding, we have a spiral binding and book binding also available tomorrow. So client code keep changing. So in binding area now it is thinking I should go with the spiral binding or book binding, or in while communicating to the other people I should go with the faxing or emailing, and in printing also if I have other options also. So client code is changing, completely messed up with the service component full, and service component itself the way it is has evolved, it is completely messed up inside each other. So for small changes in the service component side, full service component code, all three area printing, faxing, and stapling need to be changed. And if new stapling, new faxing methods are coming, then client component also need to be changed. So this leads to high confusion and leads to a new principle that was proposed by Mr. Martin. It is called interface segregation. So now things should be interface based. Now, if I have a client component and it is using printer class, it won't use printer class. It will use interfaces. Now we have three interfaces: I communication, I binding, and I printing. There are three works that is being done by. So Mr. Martin says that a client component should not be forced to use a method that it do not depends upon. So it is a role based kind of fundamental. So it is a role based fundamental in the sense that if client wants email to be sent once printout is taken, then he is not should not be forced to see the faxing code. If client wants book binding, then he should not be forced to see the stapling code. So client should not be forced to see any method that it is not dependent upon. So this is the scenario. Okay. Now this is from the client side. From the service component side, it should not the whatever the roles are. So there are three roles: communication role, stapling role or binding role, and printing role. All three roles should be separately defined in an interface. So the interface classes, like we talked machine learning, where we have iris data set, and in iris data set we have four features. And now four features internal data, if they change in a particular manner, they belong to one class. If they change to another particular manner, they belong to another class. So each classes, they are nothing but they are different type of iris flower data, like setosa or versicolor or like this. So in design principle also, if a class has different roles, then those roles should be kind of segregated at separate interfaces, like printing or communication or binding. So I binding, I communication, and I printing. These three interfaces will now, the client component will depend upon these three interfaces rather than the printer class directly. So client interface now depend upon three, client component depends upon these three interfaces. So we'll see further in the solid design principle, dependency inversion, where the client component should depend upon the interfaces, whereas the service component should realize those interfaces. So it can be done here also. So client component would depend upon I communication, I binding, and I printing, and these three interfaces would be realized solely by the printing class. But since they are realized, so printing class realizing three interfaces, now it is more clean, and changes at one place would change a particular interface realized part of the code only. So it is clean, or the three particular interfaces, they can be realized by three classes. This is depends upon the service component. Now client component, just think about the client component. Client component, when it is writing an algorithm, so in algorithm function, it takes three pointers now: I communication, I binding, and I printing. Now it has written code based upon the I communication or I binding and I printing pointers. Now in I binding, tomorrow if a spiral binding comes, then a spiral binding object would be passed. If in I communication, rather than sending the fax, if email comes into picture, then email class that derives from the I. So from the I communication, faxing, emailing, and these kind of class would be derived from the binding. I stapling, I spiral binding, I book binding. From the I printing, separate kind of printing object classes can be derived. Since the client components it writes the algorithm based upon the abstract interface pointers. So any object can come at the runtime. So if a client is writing the code and it is interested in sending email, then he's not seeing the faxing part at all, because faxing object is not passed, and all conform to the interface pointers. So it's all right. See the classic of using the using the interface segregation. So whenever we in a class, whenever we have the role and responsibility that is more than one, so better to separate in different classes. Rather than separating different classes, we can have separate interfaces. So we segregate the class roles in separate interfaces. Now those interfaces will be used by the client component, and those interfaces will be realized on the service component side. So this is interface segregation. Okay, now we'll move to D, solid. So D is a dependency inversion principle. So dependency inversion is, I believe, this is the something that is a Nobel Award winning, means it is very different. So dependency inversion principle is one class. So client class. So one class should not be tightly coupled with another class implementation. So the higher level class should not be using lower level class directly. That is a concern. Okay, like we gave an example, like if I have a bridge. So if I have a bridge has two pillars, and against two pillars, now I have the actual bridge. So this is actual bridge, and it is supported by two end pillars. So it is a ropeway bridge. So ropes are there from the pillar, and they are tied on the bridge road. So if this is bridge road, then the bridge road has hooks, and two side pillars are there, and these pillars has ropes. They are hooking into the road. Okay, bridge road. Now if there is some maintenance in the bridge road, and in the bridge road, or some new area is replaced, then it would have different specification, and rope would not be fit into it. If that is the scenario, full bridge needs to be changed. Okay, so if there is a bridge, and if there is change in any part of the bridge, since all are tightly coupled to each other, full bridge needs to be changed. Like if I have a chassis, on top of chassis I have engine, on top of engine I have brakes, and then I have accelerator, and I have steering. Okay, if all are tightly coupled with each other, then if chassis is changing, then full need to be thrown. If engine is changing, then steering and then all other brakes and everything need to be thrown. Okay, so if higher level is tightly coupled with the lower level, okay, as per the implementation, it means they are calling methods here and there. Then if lower level is changing, then higher level need to be thrown, because lower level will bring new specification, and based upon that higher level will come. So this is not that something is desired in the software level. Okay, so I mean at hardware level also. Just think about a chassis. So I have a chassis first, and then engine. So engine and chassis, they are connected with the some hooks, or some kind of rollers, or some kind of pulleys. So those pulleys are interfaces. So engine sits on chassis not directly. The engine sits on chassis through some fixed interfaces, means through fixed specification. Now, if chassis is changing, then new chassis is coming, and it is following the interfaces what the engine is providing, then it can be hooked in. So now same old engine is dependent upon the interfaces, the nut and bolt and pulleys or lever, or whatever is in between, in whatever is connecting the engine and the chassis, those specifications, the distance between them and what their type are, those specification should be constant. If that is constant, then engine is based upon an interface, and interface is now is realized by the lower level. So this is dependency inversion. If higher level is tightly coupled with the lower level, then the solution is lower level should be implemented as should be realizing an interface. So lower level should not be a class directly. So lower level is a class that is derived from or that is realizing an interface. So higher level, lower level. In between one interface, lower level realizing the interface and higher level is using the interface. Higher level dependent upon the interface. From the interface, lower level derives from it, or it is realizing the interface. So this kind of architecture, if we think, then just think that now we have churches. So churches is an implementation, and it is implementing an interface. That interface is being used by the engine. So engine depends upon the interface, and interface is being realized by the churches. Now think about engine. Engine itself is realizing one interface, and that interface is being used by brake system, accelerator, and steering. Now steering is depend upon the engine interface. From the engine interface, engine is implemented, realized. Now engine depends upon the chassis interface, and from chassis interface, then chassis is realized. Now they all are decoupled, and they are coupled only through interfaces. Interface has a fixed specification, so anyone can change now, because everyone depends upon their specification. So anyone can fit it. So I can fit a new engine because the upper layer that are steering, brake, and accelerator, they depends upon the interface. They depend upon the specification. So if new engine following the interface specification, means they realize, then it can fit in. So any component in the layers, they can be changed or they can be used at kind of in different scenario. So this is dependency inversion. So higher level was dependent directly on the lower level. This dependency is inverted, modified, diverted to higher level depending upon interface rather than directly on the lower level, and interface is being derived by the lower. So we started discussion with the solid design principle with the single responsibility, where each class must carry single responsibility. This should have only one reason to change. If a class has more reason to change, like printer we showed, it has more reason to change in a sense that it has communication criteria, and it has stapling criteria, and it has printing criteria. If a class has more reason to change, then better to place different classes. Okay, so as per the single responsibility, open close principle, whatever code we are writing, either function code, module code, or class code, once it is done, then it should be done forever. If we want to do any modification, we should be doing it either through decorator design pattern or through extending it through inheritance. So that we saw in the open close principle. Okay, so single responsibility principle generally we use in command design pattern, and open close principle generally we use in strategy design pattern. Then we have a Liskov substitution. If we have written a class, if my class depends upon other class, then other class must be substitutable by any of its subclass as it is. So this, like we give the iterator design patterns. If iterator depends upon any container class, then okay. So if I have if iterator depends so iterator has if iterator depends upon a container, then container should be substitutable by any of its subclass, or other way also, If code is written based upon the iterator, then iterator should be replaced by any of its iterator subclass. So that is the scope substitution principle. Then we came to interface segregation principle, where that now if we have a class and it has many roles, responsibility, and then it should be segregated into the interfaces in a way that client component must not be forced to see the methods in the interfaces. If you see interfaces which it do not use, okay, it is also used in strategy design pattern. And then dependency inversion, the I say the king of the design principle, where the two components must depend through interface rather than direct implementation. And if they were depend upon each other, if higher level depend upon the lower level should derive from the interface, and interface should be not used at the higher level. So this is also generally used in strategy design pattern. But when we talk about the kind of the higher level using the interfaces, then interfaces objects that is injected into the higher level is also called dependency injection. So those injection should be done loosely, not tightly through. So in C++, it can be done through factory method. This is what we discussed. So if the client component is in C part and C++ part is the service component, then through factory method, client component can use C API, and C API can use factory method. Factory method class can itself behave as the service component. It can return its own pointer. This is a matter of research, and factory method behaves as both, as it provides the factory method, actual factory method, and it provides its own pointer as the reference to the implement service implemented component. And once the C part also receives the service implement component, it can start calling it. So this is a summary. In summary, the full solid design principles. So please feel free to use it candidly and openly, and make your software bug free, component oriented, and then last forever.